f is from x to y, then g is to be from y to x. G is from y to x, such that f dot g is equal to g dot f equal to the identity function. Then we call this g as the inverse of f, which is denoted by f inverse. You don't read it as f raised to minus 1. It is only a notation or a symbol which is for inverse of f. So, for example, if you have an x here, we know under the function f, we will have the image as f of x. Now, inverse is another function which is defined from y to x, from the second set to the first set, such that f dot g equal to g dot f equal to I. Now, one thing which I've learned is that f is invertible if and only if f is 1, 1 and onto. If f is 1, 1 and onto, then only the inverse g becomes a function. Yesterday, so this is very important to know. Only if f is 1, 1 and onto, or only if f is bijective, this function is invertible. Now, today's our topic is how to prove that a function f is invertible and how to find the inverse of the function. R minus set 3 by 5 defined by f of x equal to 3x plus 4 by 5x minus 7. Prove that f is invertible and find f inverse. So here f is defined from one set, that is which set? It is R minus set 7, 5. So here we have the domain. The domain of the function is, this is R minus 7 by 5, means the set of all the real numbers except 7 by 5. So 7 by 5 is removed from here. The 7 by 5 is removed, and this is your real numbers. The function is defined from this set to another set, that is the codomain, and the codomain is also one set R minus 3 by 5. So this is your real numbers, and from there one number is removed, R minus 3 by 5. 3 by 5 is not there. So except all the real numbers are there. Now the first part, this question has got two parts. The first part is that f is invertible. You have to prove that f is invertible. The second part is find f inverse. Now logically, if you think, prove that f is invertible means it is enough to prove by using this. This is actually a theorem only. F is invertible if and only if f is 1, 1 and onto. So in order to prove f is invertible, it is enough to prove that f is 1, 1 and onto. Or in other words, if f is 1, 1 and onto, then f is always invertible. If a function f is bijective, then f is invertible. Bijective means 1, 1 and onto. Now, what is the procedure for showing f is 1, 1. Let us just recollect what you have learned in the previous class. Here is your x and its image here it is given as 3x plus 4, 3x plus 4y, 5x minus 7. This is the image. You have to prove that this function is 1, 1. What is the procedure? Let you have learned in the previous classes f of a equal to f of b implies a equal to b. Then f is 1, 1, where a and b are coming from the domain. Okay. A and b are the elements of the domain of the function. So here also we consider like that. You consider two elements a comma b from the domain of the function and you assume that let f of a equal to f of b. Now we try to prove that a equal to b. Now what does it mean? F of a equal to f of b means f of x we have 3x plus 4y 5x minus 7. Then what is f of a? F of a will be 3a plus 4 by 5a minus. It will be 3a plus 4 by 5a minus 7, which is equal to f of b is 3b plus 4 by 5b minus 7. b plus 4. So that implies 15ab minus 21a opening the bracket plus 20b minus 28 is equal to, on right hand side what you get, 15ab plus 20a minus 21b minus 28. Left side, so we'll get 20b plus 21b is equal to this 21a equal to b. So you have started with f of a equal to f of b and you have shown that a equal to b. So therefore we can write that f is 1, 1. So the first part over 1, 1. Next part you have to show that f is on. Your f is from here, your x is here and its image here is 3x, sorry 7x plus 4, 3x plus 4 by 5x minus 7. Now to prove f is on 2, you have to consider the codomain. What is the codomain here? Codomain is your R minus set 3 by 5 and your domain is R minus 7 by 5. Now to prove f is on 2, you take any element from this codomain and you have to say that there exists, for every element there exists a pre-image in the domain of the function. This only you have to show. How to show that is, we have already mapped to this point. Reverse mapping should go like this. That is f mapping, the function f is going from x to this point. Then the reverse mapping f inverse actually goes with this red color line. So now just to see, you consider a general point in the codomain. So you just call this image as y. अगर ये y होगा तो हमको the pre-image will be your x. Only for this particular point I am talking about, only for this particular point, if you consider this point as y, then its image, pre-image is x. And after that you will ask this question whether y can be extended throughout this codomain or not. That means if y is a representative element of any element from this codomain, whether you will be able to find a pre-image in the domain. So for that, first of all, you just see this root. Y is going back to actually x, but when you talk about y, when you are going back, it is actually x, but now you write x in terms of y. In terms of y, you think x, and what is the relation between x and y that you get from here? We know that y is equal to, let y equal to 3x plus 4 by 5x minus 7. Y you have taken like this is, when you take y and going back to x, this is, there is some discrepancy. When you are starting with y and going back to x is not correct. This x should be in terms of y. So when you say, if you are taking the reverse mapping, if this is your f inverse or if this is your g, then the image of y should be in terms of y. That is the purpose why you write x in terms of y. So we have considered this just to see what is x in terms of y. So how you will convert x in terms of y? At present we have written y in terms of x. At you will be writing x in terms of y. Okay. So for that, what you need to do is you cross multiply and find what is x. Finding x means solving for x. This is actually what we have here is an equation. Now your aim is to write x in terms of y, or in other words, you solve for x. Solve for x. That means you write, you cross multiply, and what you get is 5xy minus 7y is equal to 3x plus 4. Solving for x means you consider all the other variables just like a constant. Just like a constant, but it's not a constant. Okay. So solving for x means you will only look at the x terms. We have here two x terms. One is 5xy, another is 3x. These x terms you take together and take x outside. So next step is, when 5xy, say you are taking x outside, you will get 5y, and 3x is taken to left side becomes minus 3x, and x is taken out. Now keep all the y terms to the other side. Y terms as well as a constant to the other side. So we'll get 4 plus 7y. Now from here you will get the value of x. What is the value of x here? Therefore, x equal to 4 plus 7y divided by 5y minus 3. Now listen children, see here what we did is, you have written x in terms of y. So this question, your aim was to write x in terms of y, and we got it as 4 plus 7y. After this, what you need to do is, you now extend the value of y to the whole domain. Y is actually a particular point you have taken from the domain, codomain of this function. This is your codomain. From there you have taken y. Now can you extend y to every point in this set? If you extend this to every point in the set, whether you will get such 4 plus 7y, if you are extending that for every point, whether you will get a 4 plus 7y by 5y minus 3, which is present in this domain of the function. This, if it is possible, then f is onto. Now how to extend this y to the whole set here? And what is the set here? You see, the domain of this reverse mapping, or the second set I'm talking about, if y represents any element from the second set, this is your second set, what happens? If y is any element of the set, a y can be anywhere, y is taken here, and if y is in R minus set 3 by 5, will you able to get a 4 plus 7y by 5y minus 3 in this set or not? This is your question now. Y is any element from this set, R minus 3 by 5, and here we are getting what? 4 plus 7y by 5y minus 3. Whether this point can be an element of here. There is only one problem here for this expression. What is that? 5y minus 3, the denominator should not be 0. If the denominator 5y minus 3 is not equal to 0, then this expression 4 plus 7y by 5y minus 3 is always a real number. Real number belongs to this first set. Is it possible or not? Expression becomes a real number if 5y minus 3 not equal to 0. So we can say that 4 plus 7y by 5y minus 3 is always there in R minus 7 by 5 whenever y is from R minus 3 by 5. You mind that your set is R minus 3 by 5. That means y can never be equal to, y is never equal to 3 by 5, right? Because y is from R minus 3 by 5. So y, R 3 by 5 is not a point in this set. So y can never assume 3 by 5. When y is never is equal to 3 by 5, then your expression, this expression is always a real number, and when it is a real number, definitely it is there in R minus 7 by 5. That means if for every y in R minus 3 by 5, you will be able to find out a 4 plus 7y by 5y minus 3 in this set such that y is the image of this. So this is a way you have to prove that f is onto. So for onto ke liye this theoretical definition is very y we get 4 plus 7y by 5y minus 3 in this R minus 7 by 5, and this is R minus 3 by 5. Okay, so next is, that is 4. We say that this element is a pre-image of y. There is theoretically, how do we say is such that f of 4 plus 7y by 5y minus 3 is equal to y. So this there exists, that is our checking part. This only, whether there exists, that checking part only I have told you now. For every y there exists or not, that only you have to find out. There exists this in this set. This is the first part of checking, and the second part is telling that 4 plus 7y by 5y minus 3 is the pre-image of y. Theoretically, to say you will use this, your function f will be using to say the two ways it is used to say that y is the image of this, and also this is the pre-image of y. So therefore f is onto. So when f is 1 1 and onto, f is 1 1 and onto, therefore f is invertible. When you write f inverse, you or whatever function you are applying, you have to say two things from where to where it is defined and what is the image. F inverse is defined from where to where. It is from R minus, that is the second set, R minus 3 by 5 to the first set. First set is R minus set 7 by 5. 7 by 5 such that this is a way you express a function such that f inverse y equal to, what is f inverse y? It is its image of y in the reverse mapping, that is 4 plus 7y by 4 plus 7y by what you found out is 5y minus 3. 5y minus 3. So this is the final answer.